You walk into a supermarket and pick up a red berry. You do not smell it first. You do not watch another person eat it and wait 3 days. You just put it in your cart. But for most of human history, eating something new was not shopping. It was a gamble. A leaf could feed you. A root could save your life. A mushroom that looked almost identical to yesterday's dinner could kill you before sunset. So how did your ancestors figure out what was safe to eat? The obvious answer is trial and error. But the real answer is far stranger.
Because if every ancient human personally tested every unknown plant, fruit, fungus, shellfish, and animal, your species would have spent an absurd amount of time poisoning itself. Survival required something smarter than random guessing. It required a living system of detection, memory, observation, culture, and sometimes very costly mistakes. Long before nutrition labels existed, your body was already carrying clues. Start with taste. Your tongue is not just there to make food enjoyable. It is part of an ancient chemical warning system.
Sweetness often signals energy-rich carbohydrates. Saltiness can signal minerals your body needs. And bitterness? Bitterness is complicated. Many toxic compounds produced by plants taste bitter. Plants cannot run away from animals, so some evolved chemical defenses. Alkaloids and other compounds can make leaves, seeds, or roots unpleasant or dangerous to eat. That means a sensitivity to bitterness could sometimes keep an animal alive. If your ancestors followed one simple rule, like bitter equals death, they would reject many edible foods. If they assumed sweet equals safe, they could still make fatal mistakes. So taste was never a perfect detector. It was a clue. Psychologist Paul Rozin spent decades studying disgust and food rejection. His work helped show that humans do not respond to food based only on calories or flavor. Ideas, memories, social information, and perceived contamination can completely change whether something feels edible. A perfectly clean drink can suddenly become disgusting if you believe something revolting touched it. The chemistry may barely change. Your mind does. That reaction is not random. Disgust can act like a behavioral immune system, pushing you away from things associated with pathogens, decay, bodily waste, or contamination. Imagine your ancestors finding an animal carcass. The meat is available, but it smells wrong. The texture has changed. Flies gather around it. Other members of the group hesitate. That hesitation matters. Rotten food can contain dangerous microbes and toxins. You do not need to see bacteria to evolve behaviors that reduce your exposure to them. Individuals who avoided certain signs of decay could, on average, have had a better chance of surviving long enough to reproduce. Your nose became part of the system. Your eyes became part of the system. Your stomach became part of the system. And your memory became one of the most important parts of all. Suppose you eat an unfamiliar berry. Hours later, you become violently sick. Even if the berry was not actually responsible, your brain may form a powerful association between that flavor and the illness. For many kinds of learning, a long delay between an action and a consequence makes the connection harder to learn. But food poisoning often does not strike instantly. A system that only connected immediate pain with food would miss many real threats. So your brain is unusually prepared to learn one particular lesson. I ate that, then I got sick. Do not eat that again. One bad meal can change your preferences for years. You may have experienced this yourself. A food you once loved becomes almost impossible to swallow after one night of vomiting. Your rational mind may know the food was innocent. Your stomach does not care. Now imagine that learning system operating in a world with no hospitals, no poison control centers, and no search engine. A mistake could be expensive, but your ancestors had something more powerful than individual memory. They had other people. A child does not enter the world with a complete list of edible species. Instead, the child watches. What does the mother eat? What does the group collect? Which fruit is peeled? Which root is soaked? Which part of the animal is discarded? Which mushroom does everyone ignore? This is social learning, and it changes everything. Instead of every generation restarting the experiment, knowledge can accumulate. Anthropologist Joseph Henrich has written extensively about cumulative culture, the process through which useful knowledge builds across generations, often becoming more complex than any single individual could easily invent alone. Consider a plant that is poisonous when raw, but edible after a complicated preparation. Maybe it must be crushed, then washed, then soaked, then cooked. Why would the first person ever discover the entire sequence? Sometimes the answer may be gradual experimentation. Sometimes different steps may originally have served different purposes. But once a successful method exists, people can copy it without fully understanding the chemistry. That is the strange power of culture. You can know how to survive without knowing why the method works. Some ancient food rules may have looked like superstition while still protecting people from real risks. Do not eat that animal. Do not collect shellfish at that time. Cook this food in this particular way. Avoid this plant unless it has been prepared by someone who knows how. The explanation might be mythical. The behavior could still be useful. Of course, culture can also preserve mistakes. Humans copy one another extremely well. That is both a superpower and a vulnerability. But in a dangerous environment, copying trusted people is often safer than independently testing everything with your own stomach. Who do you copy? Usually not everyone equally. You may pay more attention to successful hunters, experienced gatherers, older relatives, skilled healers, or people who seem healthy and competent. Researchers studying cultural evolution often describe biases in social learning. Humans can preferentially copy prestigious individuals, successful individuals, or the majority. That means food knowledge can spread through a group without every person personally verifying it. You see 10 people eating the same fruit, you're more willing to try it. You see everyone avoiding one bright mushroom, you probably leave it alone. But what happened when your ancestors entered a completely new environment? That was the dangerous part. As humans migrated across landscapes, they encountered unfamiliar ecosystems, new plants, new animals, new seasons, new parasites. The old menu did not always travel with them, so observation became critical. Could humans simply watch what animals ate? Sometimes. But this method has a serious flaw. An animal can safely eat something that poisons you. Different species have different digestive systems, enzymes, gut microbes, and tolerances. A bird may swallow a berry that contains compounds harmful to a human. A koala can survive on leaves you would never consider dinner. A vulture can consume decaying flesh under conditions that would be dangerous for you. So animal behavior is evidence, not proof. The same is true of appearance. Bright colors can signal danger in nature, but sometimes they signal ripeness. A pleasant smell can attract you. Ancient humans were not walking around with a magical instinct that perfectly identified every edible plant. They were managing uncertainty. And they probably did it with layers of information. Does it resemble something known? Do animals eat it? Do trusted people recognize it? Does it smell rotten? Does a tiny amount cause irritation? Has the group prepared it before? Is there another food available that is already known to be safe? That last question may be more important than it seems. You do not need to test a mysterious mushroom when you already have enough food. Your ancestors were making decisions under pressure, and then there was fire. Cooking transformed the problem. Harvard primatologist Richard Wrangham has argued that cooking played a major role in human evolution. Cooking can make many foods easier to digest, increase the energy your body can obtain from them, soften tough tissues, and kill many pathogens. But fire does not make everything safe. Some toxins survive heat. Some dangerous foods become safe only through specific preparation. Some foods can become harmful when stored badly. Still, cooking expanded the human menu. A hard root becomes softer. Meat becomes easier to chew. Microbial risks can fall. The night around a fire also creates something else. Imagine food knowledge being transferred without writing. A child watches an adult scrape a plant. Someone tells a story about a person who ate the wrong berry. A hunter explains which organ should not be consumed. An elder remembers where a certain fruit appears after the rains. The information is repeated. The information becomes tradition. The tradition becomes invisible. Human survival required flexibility. This may also explain why cuisine is so deeply social. Food is not merely fuel. It is information packaged as tradition.
A recipe tells you which ingredients belong together. A taboo tells you what to avoid. A cooking technique tells you how to transform something. A meal shared by the group tells you without a laboratory test that this is probably food. The table is a database. And for most of history, it was stored inside people. But someone, somewhere, still had to make discoveries. So were ancient humans constantly dying from experiments? Some certainly died from poisoning. Contaminated food, allergic reactions, toxic plants, spoiled meat, and dangerous preparation. There is no reason to romanticize the process. Knowledge can be built from tragedy.
But discovery did not always require swallowing a full meal of an unknown substance. Humans can investigate cautiously. They can handle something, smell it, observe its effects, try a small quantity. No single method is perfectly safe, and reconstructing exact prehistoric testing procedures is difficult. Your ancestors were not simply guessing. They were learning individually, socially, across generations.
And sometimes the most important knowledge was not the name of a poison. It was the habit of listening to someone who knew more than you. Think about how extraordinary that is. A person can die, but a warning can survive. A bad experience can become a story. The story can become a rule. The rule can become a ritual. The ritual can last so long that the original danger disappears from memory. Culture allows information to outlive the brain that learned it.
You still use taste. You still use smell. You still watch other people. You still trust cultural knowledge. You still learn from one terrible meal. The difference is that the experiment has become almost invisible. So how did ancient humans know what was safe to eat? They often did not. Not at first. They tasted the world carefully, remembered what happened, watched one another, copied the successful, warned the young, transformed dangerous ingredients, and passed the results forward.
Until one day, thousands of generations later, you could walk into a supermarket, pick up a red berry, and never even think to smell it first.